The aging human body faces a quiet failure of intracellular housekeeping. Every 24 hours, damaged proteins, mitochondrial byproducts, and oxidized lipids accumulate in your heart and skeletal muscle fibers. As this cellular waste load rises, contractile efficiency falls, diastolic filling stiffens, and muscles lose power long before you reach chronological old age. Disclaimer. This content is for educational purposes only and does not constitute medical advice. Always consult a healthcare professional before beginning any new supplementation or longevity protocol. Taurine appears to be a powerful longevity lever in animal models, but in humans it is best described as a promising, mechanistically compelling, yet still unproven semi-essential amino acid for healthy aging. In 2023, Singh and colleagues published a landmark paper in the journal Science titled "Taurine Deficiency as a Driver of Aging." They reported that circulating taurine levels fall markedly with age in mice, monkeys, and humans. Restoring youthful taurine levels was shown to prolong lifespan in animals and improve multi-organ health. In mice, serum taurine declined from approximately 132 nanograms per milliliter in youth to just 40 nanograms by middle age, representing a statistically robust decline with a highly significant p-value. In both monkeys and humans, the researchers reported roughly 80 to 85% lower serum taurine in older versus younger individuals, suggesting that taurine depletion is a conserved feature of mammalian aging. When middle-aged mice receive 1,000 milligrams per kilogram of taurine once daily, lifespan increased by around 10 to 12%, and life expectancy late in life rose by nearly 25%. Parallel experiments in worms showed up to 23% increases in maximal lifespan, confirming that the longevity signal is conserved in at least one invertebrate model. At the mitochondrial level, taurine enters the organelle and forms a specific modification on mitochondrial transfer RNA. This modification is critical for the translation of the complex 1ND6 subunit. In aging tissue, this modification can be reduced by more than 60%, leading to a collapse in respiratory capacity. Restoring taurine levels prevents most of this decline, limiting the loss to about 20%. This links taurine directly to mitochondrial respiratory capacity, and by extension, the bioenergetics of every beat of your heart and every contraction of your muscles. However, for the longevity logic lab, we must look at the total evidence. A 2025 analysis by Fernandez and colleagues challenges the notion that taurine universally declines with age in humans. Using longitudinal samples from hundreds of participants in the Baltimore Longitudinal Study of Aging, they found that circulating taurine often remains stable or even increased with age, especially in women. This tension emphasizes that taurine is unlikely to be a universal linear aging biomarker in humans. Therefore, any world-class protocol must lean on randomized human trials focusing on intermediate endpoints. A 2024 meta-analysis pooled 20 randomized controlled trials with over 800 participants. The results showed that taurine supplementation significantly reduced heart rate and lowered systolic blood pressure by approximately 4 millimeters of mercury, while improving left ventricular ejection fraction by nearly 5 percentage points. For those seeking to use taurine as a tool for biological optimization, our lab suggests a tiered framework of layers. Layer 1 focuses on baseline status. Before beginning supplementation, a research-aligned protocol prioritizes a baseline evaluation of blood pressure, lipids, and resting heart rate. It is also essential to estimate current dietary taurine intake because typical Western diets deliver modest amounts, while strictly plant-based diets can provide virtually none. Layer 2 addresses cardiovascular modulation. Human cardiovascular data cluster around a 1.5 to 3 gram per day dose range. A reasonable starting target is 1.5 grams per day, divided into 500 milligram doses taken 3 times daily with meals to ensure steady systemic exposure. Layer 3 focuses on skeletal muscle performance. In older adults, modest doses of 1.5 grams per day have been shown to improve grip strength when combined with structured resistance training. Layer 4 targets mitochondrial maintenance. To match the profound mitochondrial effects seen in animal models, humans would require doses in the 5 to 7 gram range. However, because long-term human safety in this range is undercharted, a safety-weighted protocol remains within the 3 gram per day window, combining taurine with endurance exercise to naturally augment internal levels. Taurine sits at the intersection of mitochondrial stability and metabolic control. While we await large-scale human lifespan trials, the evidence for cardiometabolic and muscle supportive benefits is statistically significant. For now, taurine is best understood as a targeted intervention that should be integrated cautiously under professional guidance. Disclaimer. This content is for educational purposes only and does not constitute medical advice. Always consult a healthcare professional. For the complete clinical protocol summary, dosing spreadsheets, and our lab-vetted sources, visit the Longevity Logic Labs Protocol Hub linked in the description below. We update this database in real time as new clinical data and purity batches are verified. Thank you for supporting evidence-based science. Subscribe to stay updated on the latest longevity logic.